Hello and welcome to Atheists Talk. My name is James Zimmerman. I'm going to be your host for this episode. This is an episode that we are discussing climate change. This is actually the second part, so if you're watching this one first, go back and watch part one first because we'll give more of an introduction on that one. But my guest today is Greg Laden. Welcome, Greg.
Thanks. Great to be here.
Greg is a science communicator and teacher. He's studied the relationship between human evolution and ecology and climate change during the Holocene, and also African and North American prehistory. And you've addressed, mostly through writings on National Geographic science blogs, the science of climate change, and you've presented several talks and workshops about the issue of climate change. You're currently working on two books. One is on your fieldwork in the Congo, and the other is a novel which takes place after the climate's been ruined, right? And because of climate change. And you told me that you hope that it's just a work of fiction and not prediction.
Right.
Also, you have an essay that appears in the book Atheist Voices of Minnesota, which was published last year. And you live here in Twin Cities, in Coon Rapids, with your wife and children. So we went more into detail in the first half about this, but let's just recap real quick. Why should atheists care about climate change?
Well, I think everyone should care about climate change. It's a current important policy and science issue, and atheists tend to be oriented towards those things. But also, think about why do atheists care about evolution and teaching evolution in the classroom? Mm-hmm. And the reason for that is in part because it's interesting and all that, but also because the anti-evolution, the creationist sort of movement is a religious-related phenomenon. And it is not the case that climate change science denialism is exactly that, but there are elements to it.
Sure.
You'll find a lot of elements to it. Quite often, organizations or individuals who are claiming that climate change is not real and are what we call denialists, what they call skeptics, but we call denialists, are doing this for religious motivations. There's a lot of overlap. It's spotty and it's irregular. There's a fair amount of overlap between the two.
Okay. Yeah, thank you for the explanation there. So we had a couple of extra minutes during the first half of the show, and we were touching on the increase of storms. So maybe you can go into more detail about how global warming has led to or will lead to an increase in, say, cyclones or typhoons.
Sure. This is where we have interesting science happening right now as we speak. It's a very interesting thing. If you increase the heat in the atmosphere, I guess I should have just mentioned that weather is really all about the movement of heat that is built up on the equator because the sun is shining more directly on the equator. It's a movement of that heat via air currents and water currents towards the poles. And when that movement is not simple and gentle, there's perturbations and there's things that happen that we call weather, and that includes storms and just even rain versus dry, sunny versus cloudy, but also storms. So it might make sense that if we heat up the atmosphere, that the total amount of storminess goes up. We know that when we heat up the atmosphere, we've added so far about 5% or so of the water vapor that would have been in the atmosphere 200 years ago is increased by about 5%, which is a lot. And more water vapor means more storminess and more rain in some cases as well. So right there, the premise is that we can assume storminess goes up with climate change, but how does it go up and what kind of storms become more common? When we look at tropical cyclones, in the large historical perspective, some studies have looked at, when a hurricane comes through, it tends to dump a lot of crap from the ocean well inland. Mm-hmm. And in big flat areas like Alabama and Florida, you actually can find layers in interior inland swamps of ancient hurricanes that
have dumped debris there.
Yeah, and it shows you, the Category 5. It shows you how many Category 5 hurricanes you might have over a century's time, because you won't have very many Category 5 hurricanes in one spot.
Right. Yeah.
But if you look at a century, you might have 1 or 5 or something. So looking at that, there's evidence that during the last several hundred years, there's been an increase in hurricanes where people have looked to see if there's an increase or decrease, or if it stayed the same. It tends to have increased. I remember, living in and doing historic archaeology in New England and sort of encountering the phenomenon of the 38 storm that hit New England. It actually affected me as a kid going to the Adirondacks and climbing, because up in the Adirondack Mountains there's a whole bunch of blowdowns that were caused by this storm that are still there. Mm-hmm. Okay, and what I learned was that, interestingly, people in Long Island and the coast of Rhode Island and Connecticut had never heard the word hurricane before. These are fishermen who spend their lives at sea dealing with storms. And they had storms, they knew about storms, but there hadn't been any hurricanes that anyone could remember ever coming up to New England. And now they're fairly common. They come up every year.
Yeah.
They at least go by every few years. They hit New England. Sandy last year. We didn't have anything this year. So there's a general sense that there might be more storminess, but is that accurate? Is that really accurate based upon the data? We have lousy data when you go back several decades, so it's not easy to say. Sure. Okay, so there are studies now that show an increase in how severe Pacific storms are, and how frequent Atlantic storms are. There's a couple of studies that show that storms might be stronger and more frequent, but not in such large numbers that it's really obvious. You have to look at the data, and it's kind of hard to see it. So people are legitimately saying we're not sure that tropical cyclones would be more severe or more common, but a lot of climate scientists think that they will be and are starting to show that signal. What has happened that is just a few instances, but is very concerning to me, is this. Hurricanes form when you get a certain water temperature in the sea. If it's not warm enough, you won't get a hurricane forming. And it's warmer, you get a stronger hurricane. When you have a larger area of warm water, you have more chances of hurricanes forming. And the hurricane can spend more time over that warm water and get bigger and stronger over time. When Yolanda Haiyan hit the Philippines, we're currently in the middle of the winter time. It's about January 2nd, 2014. And last hurricane season, we had a record low hurricane season in the Atlantic. But Yolanda hit the Philippines and did some very serious damage there. And I was talking about this, involved in a conversation with a bunch of climate scientists who were looking at this. Somebody pointed out, why is this storm so strong? Because we looked at the sea surface temperatures over the area that the storm went, and they were warm enough to form hurricanes, but they weren't exceptionally warm. They were kind of average warm.
Okay, yeah.
And this is perplexing that this storm had gotten so strong, was average hurricane level, and it was a very strong storm, maybe one of the strongest storms that we've ever observed. Someone then came up with some more data, and looking closely, it turns out that at depth, many tens of meters down, the ocean was still warm enough to form hurricanes. Like if you peeled off the top 50 meters of ocean, the water at that depth would still be warm enough to form a hurricane.
Oh, okay.
So as the hurricane's moving across the ocean, it's churning up the water and bringing cold water up and cooling off the surface. So the back end of the hurricane actually gets less energy than the front end because the front end's messed it up. But if your water temperature is warm enough to form a hurricane at 100 meters or 50 meters, it doesn't happen. Okay? Turns out that the other big hurricane that did that was Katrina. People noted at the time. Katrina is famous for having moved over a gyre of hot water in the Gulf, and everyone who follows these things closely will remember that. And that helped it get strong, kicked up its strength a bit. But that's not what I'm talking about. I'm talking about during its entire course, the Gulf was hot at a higher depth.
So it churned up hot water instead of
cold water,
giving it more energy.
If that's a thing, that might actually be, you would almost think of that as a qualitative difference. The ocean is qualitatively different. It isn't that it has a surface that's hot, but it has high heat at depth, which means that sometimes hurricanes can become super hurricanes, like Katrina or Yolanda. And so we may not get that many more hurricanes, and not very many hurricanes will have this happen to them. But if every couple of years we have one or two of these, that would be a new phenomenon. So so we're not sure about tropical cyclones. I think everyone in climate science kind of expects them to get more of something, more frequent, but maybe not in every ocean basin.
Okay.
And the jury is still out, but it's qualitatively different kind of storm. The other thing that happens that was very unusual last year was Sandy, which started off as a hurricane and became a superstorm, which is bigger than a hurricane, it turns out. And normally hurricanes that go up the Atlantic just end up going up to some remote place. We don't even know where they go. They just, like no one's ever been there.
Yeah.
Just hurricanes go there and they dissipate. Her Sandy turned left and hit Connecticut, New York, and New Jersey. And there's two things about that. First of all, we think the steering winds that caused the air masses that caused Sandy to turn left and hit the East Coast are part of a larger phenomenon that is a result in part of global warming. Plus, New York had a foot more water in the ocean because sea levels have gone up a foot over the last century.
Oh, okay.
And that translates into something like 10 feet when you turn it into storm tide with a storm that big.
Okay.
Okay. So even if we had the same number of hurricanes and the same strength of hurricanes, they're all worse because hurricanes always come from the ocean. The storm tide is always one of the big factors in a hurricane, and the storm tides will be bigger with increased sea level rise.
Are we seeing more problems in the larger, deeper Pacific then, or the Atlantic?
It's not clear.
Okay.
The thing is, the amount of natural variation that happens between years in those basins is so large that it's very hard to say. We had an extremely unusual year in the Atlantic. What happened in the Atlantic this year is there were really almost no hurricane activity, but the best models for predicting these things actually predicted kind of 12 named storms, I think. Or let's say 12 named storms was within one standard deviation of the model's prediction, at the low end probably. And 12 named storms is fine, but they mostly weren't hurricanes, so it really was a wimpy hurricane season.
Okay.
But what happened was the Sahara did something unusual. It does it now and then. It just blew a huge amount of dust across the tropical Atlantic, and that dust attenuated a lot of the things that cause hurricanes to form. So the dust basically wiped out the hurricane season this year.
And you touched on sea levels. Maybe you can expound on that a little bit more. How much sea level rising has happened or is expected to happen? Yeah,
this is actually a topic it's how I originally got into studying climate change back in the 80s when I was doing coastal archaeology in New England. And it's, to me, just a very interesting topic. And it's also where we have the biggest unknowns. We look at temperature change over time. The models people developed years ago are coming true. The rate of ice melting in the sea ice melting in the Arctic is much greater than predicted, but it's still there's a model range of predictions, and we're outside the model range.
Okay.
With sea level rise, I think we're at sea, literally. The IPCC report, which came out last year, the Intergovernmental Panel on Climate Change, the UN body that kind of summarizes the science, came out with a line of sea level rise, like how much it would go up. Since that came out, that line solidifies research that's really maybe 6 months old to a year old in some cases. Since that line was kind of solidified in that process, several studies have estimated sea level rise, all of which are higher than what they're saying. So in other words, right now the science is shifting towards more and more extreme sea level rise. Mm-hmm. If we have 400, 500, 600, 700, 800 parts per million of carbon dioxide, if we're up there over 500, we have 400 now. We're up there at 600, 700, closer to 1,000, which is extremely high, parts per million carbon dioxide. You can expect the glaciers to probably melt at the rate of something like 80%. If 80% or more of the glaciers melt, the sea level, if you go online, you can find places online where you can turn a virtual dial and watch the ocean go up.
Yeah.
Okay. They're all
to see how it affects the coastal areas?
Yeah.
Okay.
And they all go up maybe 6, 8 feet, 12 feet. Okay. If all the ice melted, we're talking about hundreds of feet. Mm-hmm. Okay. The entire state of Florida would be completely gone. The Appalachians, the forest slopes of the Appalachians would be near the coast. It would be a short drive to New Orleans from Minnesota if they moved the city with it. You know. The sea would touch possibly Niagara Falls. New England would be an island.
Oh, wow.
Now, this is extreme. This is like all the ice melts.
Yeah.
It might take 1,000 years to melt all the ice, okay? I'm not saying that that's going to happen right away. But the amount of sea level change is huge. It's hundreds and hundreds of feet from the lowest sea level, which we are, during the Pleistocene, to the highest, is an awful lot of ocean. And
even 6 to 8 feet, you could wipe out some countries, right? I mean, Pacific.
Well, Kiribati will probably be wiped out with 1 foot more. Thailand, it has mountains and stuff, but they grow a lot of rice in Thailand. It's like it's a supplier of rice for a large region. Bangladesh also.
Oh, sure, also
those areas, the lowlands are major agricultural areas, and just a couple of feet. People don't realize this. You turn the dial on the map that's online, and the sea level goes up. Okay, so you want to see what it looks like when the sea level is 6 feet higher. So you find the 6-foot topo line, right? That's not where the sea will be. If the ocean goes up 6 feet, it's not going to find the 6-foot topo line and stop there. It will erode across the landscape, perhaps a great distance. Mm-hmm. It depends on if it's all rock, it won't erode it so much. When I was a kid, I remember being very impressed with the Marconi antenna footings on Cape Cod. These are footings placed in a 100-foot square for Marconi's antenna when he made his first transmission of a radio signal to France. first transatlantic transmission.
Okay, yeah.
And they're sitting there on Cape Cod. When I was a kid, you could see you walk between all 4 of the footings. 20 years later, I went back there and visited again. There was 1 footing left. So the hypotenuse of a 100-foot diameter square of Cape Cod was gone.
Mm-hmm.
Okay, and so that's 100 foot of horizontal movement of the ocean
Yeah.
with a few millimeters of sea level rise. In other words, that's the sea level coming up from the Pleistocene is still eroding. In other words, the sea is already encroaching on land, even if it doesn't go up in some places. It's already encroaching on land. You add a foot or two, and it just significantly adds to that. So between the storm tides, so the way I like to think about it is we don't really know how fast these glaciers are going to melt, and we really have no clue whatsoever. We have no idea. We just know that when the carbon dioxide in the atmosphere is several hundred parts per million above baseline, and we're now close to doubling it, the sea levels in the past were up an alarmingly large amount more than they are now. That may not be enough. The rate of melting might not be fast enough that anyone alive today would see it, or maybe it is fast enough. We're not sure how fast glaciers melt. I like to think of it like imagine a giant, ice sculpture. Here in the Twin Cities, there's a big winter festival. One of those big ice. Imagine putting a big ice sculpture from a wedding or something, a big swan, on a table, and asking a bunch of people to estimate. It's in a warm room, as the water drips off the table on the floor. At what rate? How long will it take for this swan, as liquid or whatever, to end up on the floor? What's the rate going to be? And you can measure the water dripping. You can do physics. It's this temperature, this is this much ice, and estimate the melting rate. But when one of the wings of the swan falls off and skitters across the table and crashes into the floor, that is not predictable.
Yeah.
Yet it will happen. Some of the melt will be catastrophic. Some of the melt will be a big chunk sliding off. That's the problem with glaciers. They don't just melt, they fall apart also. And there's very little good science right now on how glaciers fall apart, how big continental glaciers fall apart. We do know when we look at the ancient record, we see sea levels rising at the end of the last glacial period at a rate that is too fast to measure geologically. Just the points are just too up and down, too fast.
Too scrunched of a time.
Yeah, and the time period is too crunched up. So it could be very fast, but we just don't know. And how transgression works, how the sea moves across the land as it erodes and so on. It'll just be interesting.
Yeah.
And there are some. I have one on my blog. I just found a topo map from the USGS, and I eliminated everything up to. I think I used some very large number, something. I can't remember how many. I don't want to say here. I don't want to get it wrong. But it was a very large number of. Assume all the ice melts, and then also add several feet, because when the ocean gets up on the land, it presses the land down, and it erodes across. So I actually wanted to make a map for my novel of like where things are. Yeah. So I did an extreme version 500 years from now. It's kind of fun to look at that because it is interesting. The United States looks different.
I bet, yeah.
California is still kind of the same, but the Salton Sea is an arm of the ocean.
Oh, okay, yeah.
The Amazon is an arm of the ocean.
So in our remaining 10 minutes here, let me ask you a few questions that people say sometimes, being critical of climate change, but just to kind of tease out some of these other issues that people might have. One thing is people say, hasn't the Earth been warmer and colder in the past? You've touched on that already, but just the cyclical nature of climate through the eons. Yeah,
and it has been. And just imagine, a nice image is this. If you ever go to Las Vegas, I recommend going to Red Rock Canyon because there's nice geology there.
Okay, yeah.
You go to a place like that, or the Science Museum maybe in St. Paul, I'm not sure, but places that have geological displays. There'll always be a display somewhere that says, depending on where you go, you're standing on what was once a giant inland sea.
Yeah.
Like right here now, we are standing on what was once a giant inland sea. The reason why there's no dinosaur fossils, there's one dinosaur fossil from Minnesota, is because it was an ocean, or a sea at the time. Well, that's partly because the ocean was higher. It's not just because the land was lower. It depends on where you go. If we did have the sea level rise so much, it doesn't matter if we like the warm weather. It doesn't matter if we can adjust our agriculture. What matters is that we lose, 15% of the land that we live on in this country, which contains 80% of the population.
Yeah, some of the most valuable land as far as real estate, sure.
And so that's one effect. It isn't okay to say the Earth was once a big fiery ball of lava.
Right.
It doesn't mean that it's okay that it is now.
Yeah.
If that were to happen, right?
Yeah.
So yes, it has changed in the past. And the other thing is, it isn't like it changed without effects. Climate change in previous times when climate was very different. There were also periods of time when climate was devastatingly horrible. During the Pleistocene, during the maximum glacial, we think the biological productivity of the Earth was down so low that there were just fewer plants and animals. This is when humans almost went extinct once. There's been a few times we've almost gone extinct. And when things have been very warm, there have been periods where oceans have gone anoxic, and the sea stops producing oxygen, and the sea stops producing food. So those are kind of big things. Those are things that those went along with those climate changes in the past. We actually happen to be living in a period, the Holocene, when climate is pretty good. It's pretty productive, the ecology is pretty productive, and is relatively not that variable.
So then another question that people have, instead of looking at eons, what about just looking at decades? When I look back at even just the history of the United States, like the 1930s stands out as a time of horrible weather, and I don't think we attribute that to global warming, or do we? I mean, how would you respond to something like that?
Part of the problem there is we don't know, the nature of their records are not sufficient with storms. It does look like there's a period in the 30s and so on where there was major droughts and also some major storms. And so that may be relevant. But that is not before climate change. Climate was already changing, and CO2 was already increasing at that point in time. So it still may be a climate change effect.
Okay.
But also, these are things that vary up and down all the time anyway. So the idea of having a period of time when there were a lot of tornadoes in the 30s, if that was the case, which we don't know, doesn't mean that having 100 years of tornadoes later isn't significant. Having 8 years of a lot of tornadoes is nothing compared to having a lot of tornadoes from now on. I'm not saying climate change has caused more tornadoes, but if it did. Okay? And the other side of that, with tornadoes specifically, people say the evidence shows that there are not more tornadoes now, if you look at the actual data. But that's not true. If you look at the actual data, the evidence shows that the people who collected the data didn't do a very good job of collecting data for use in long-term climate models. The data are really lousy. So you can't say this. So we have some anecdotal information and some records of some periods of storminess in the past. But the latest work of the last year has shown, when people often complain the medieval warm period was a big warm period, and it was warmer than now. It wasn't, it turns out. We're warmer now than the medieval warm period was. We are warming up out of a relatively cool period, the Little Ice Age. We're warming up of the long term out of a relatively cool period. So it's taken us an extra few decades to get to where it's really serious. And the flip side of that, too, is people often assume that climate change is something we're worried about in the future. Why are we worried about it now? Let the people in the future worry about it, or maybe it won't be so bad. It's been happening. It's already happening. And it's already had effects globally. It turns out the United States is, of all the countries that have been affected by climate change, how badly they've been affected, the United States is kind of low on the scale of how bad it's affected us until now. We're having some bad storm systems because of climate change now that's affecting us much more, and some droughts that are much worse now. But other parts of the world have had very severe droughts for very long periods of time because of climate change. By the way, Minnesota is one of the least affected states.
Oh, really? Okay.
Yeah, probably because it was already so bad here anyway. No, it's because we're in the middle of the continent.
Yeah.
So we're buffered in a way. So we've had among the least changes in terms of effects.
And speaking of Minnesota, a lot of times, throughout our discussion here, we've used the term climate change. More popular term is global warming.
Right.
So how do you reconcile that with a state that, even as we're recording this, we have like negative 10 degrees outside, not even counting the wind chill. So how do you account for those extreme colds?
Well, it's interesting. First of all, the extreme cold we're having now is the effect of a jet stream that's dipped very far south, which is bringing us extremely cold Arctic weather. And it's also bringing extremely severe storms. The Caribbean had very bad storms on Christmas Day, and now there's very bad storms in the East Coast. That could happen anytime. That kind of thing has happened in the past, could happen anytime. But because, as part of global warming, what's happened is the Arctic has warmed up a lot more than other parts of the planet. And that has caused what's called Arctic amplification. I mentioned in our last segment that weather is all about moving heat from the equator to the poles. And as the heat moves from the equator to the poles over in air currents, certain patterns of air currents set up and work a certain way, and that gives us our climate. If you look at a map of the globe, you'll notice that all the deserts are in the same latitudinal region. Okay, that's because of the setup of the air moving from the equator to the poles sets up these patterns. The Arctic warming up exceptionally compared to the rest of the planet has caused those patterns to change, we think. And this is still early science. We're not certain of this yet. It's the kind of thing that, one of these things where it has if someone's driving down the road and a person is pushing a baby carriage out in the street, you might go over and warn them to get out of the way, but maybe you're wrong. Maybe they're not going to hit them.
Yeah.
But you still warn them anyway.
Yeah.
So this might be a really severe thing we better be careful about if it's true. Okay? And that is that with this Arctic amplification, it changes the nature of the jet stream. So instead of the jet stream being usually kind of straight necklaces of air currents around the planet, they become curvy. Sometimes. Now they're curvy all the time. The jet streams are just curvy all the time. And what this means is major storms, instead of kind of passing through, they stall and they sit there for a long period of time. So we're getting this really cold for a long period of time. The flooding in Calgary last early summer that killed many people. The flooding in Boulder. The flooding in Central Europe. The flash drought we had in Minnesota. The severe cold 2 winters back that killed hundreds of people in Siberia. These major weather events we've been having, Sandy, the current storms in the east, are cold right now. These are all a result of these Rossby waves, they're called, these wavy patterns of air, which are probably caused by a change in the jet stream configurations, which is probably caused by the Arctic amplification, which is probably caused by global warming.
So thus, climate change is the better term to use.
Because it's actually a change in the qualitative nature of the overall system.
So we have just about 1 minute left, but maybe you did this in part one too, but maybe in this segment you can just real quickly touch on a couple websites people could visit for more info. Yeah,
I write a lot about this on National Geographic's science blogs, on Greg Laden's blog. A great blog to look at, a great website to look at, it's not a blog, a great website is skepticalscience.com. It's organized around the questions people typically have about global warming, many of which we've touched on. And several of the units of information will actually have beginner, intermediate, and advanced levels. You can click a tab and get more math as you go to the right. And there's another new project. There's a Global Warming Fact of the Day is a Facebook page. That's a great place. Everybody who's involved in the community just puts up news about global warming. And now there's a website called Global Warming Fact of the Day, which has a fire hose feed of all the relevant, important stuff coming out, which we hope to organize over the next month or so. We're going to add a resource page. So you can go there and find what is the best thing, 2 or 3 or 4 blog posts or whatever, written about this aspect of climate change over the last year or two.
All right. Well, that takes care of our time. Thank you for all your information. As I can attest, we had a lot on our outline here that we didn't even get to, so certainly visit those sites and that Facebook page for more information.
Great.
And actually, to you, our viewers and listeners, if there's anything else you would like to see presented on our show or that you'd like to discuss, let us know. If you contact us, we'll be happy to give you a free copy of our newsletter so you can see what other atheist-themed activities and events are taking place here in the metro area. If you're interested in us, we're interested in you. Thank you for listening.